So if I want to solve this by completing the square, bless you. Now remember, what's going to happen in the end, you're going to get an answer, correct? And if you're given an answer and there's 4 of them, and you don't remember how to complete the square, could you just substitute and figure out what it is? Does it state that you have to specific, when you have multiple choice, it just says solve. Do you think I would be standing over your shoulder going, you didn't complete the square? Yeah, for her I would do that. I'd do anything to annoy her, because that's how I roll. But if I want to go through and remember how to complete the square here, move your constant. What's half of -1? Or, what's half of -2? So it's x minus 1 quantity squared, and I add 1 to both sides. But you can see, though, when you do complete the square, it is ridiculously quick. All right. Now with 66, you shouldn't have to worry about simplifying that, because in your head, you're like, okay, that's just 1 at 6 and 11, so it's 1, 2, 3, 11, 66, and that's it. There's no perfect squares. You go to the next problem. You're not going to see decimal equivalents. It's simplified radical form. Same thing on the other one. Add the 64 right away. We're going to get x squared plus 4x plus blank equals 74 plus blank. Well, what's half of 4? What's 2 squared? So I have x plus 2 quantity squared, and I'm adding 4 to both sides. I get 78. I love completing the square because it's fast. X equals -2 plus or minus the square root of 78. So now I want to double check, make sure 78 works. 78, if I'm not mistaken, is 4 goes into it. But how can I double, doesn't 16 work? No. How do I double check that, remember? The calculator? Good, yeah. We do the y equals, do your y equals in the calculator. Eventually. Y equals 78 divided by x squared. And then just go to your table and look for the value. And it doesn't work. All right, so it's just 1 to 78. For some reason I thought maybe 4 worked. Oh, I was thinking 79. Whatever. Okay. What else we got so far? Yeah. Sure.
Wait, 35?
I think it was 45.
Oh, okay. You made it this one? But you can just put it in.
That's what's nice. See, what's nice about something like this is you got your calculator. That's really all there is. Now, what I would say is not just the calculator, but how can I describe the end behavior? How would you describe the end behavior? So I know the tails are doing this. What's nice about a graphing calculator, probably you have a graphing calculator, you don't have to worry about it. But I might ask you to describe what's happening at the tails, you know, as x goes to infinity, f of x is going someplace else. Remember we wrote all that out?
Yeah.
Yep. Yeah, you should never get something like that wrong. That's okay. Sure. Identify the domain and range. Now, domain stands for which values? X values. So your domain is your X values, and your range is going to be your Y values. Now, in a problem like this, if you have no clue, what could you look at? Look at the graph. Okay? So if I go to my graph and I type in my y equals, we have the square root, so x plus 4. Get out of the square root, and was it minus?
Minus 3.
Okay, thank you. And I'm just going to look at my graph real quick. What's that? It's the square root. So the square root graph looks like that. Now, square root graphs is something we did not spend a ton of time on. It really, I don't think we did. I don't think we did any really. Now, what's nice about square root graphs, and this is really easy to work with. This is why we didn't spend a day on this. Square root graph, y equals square root x minus h plus k. Where your values, if it's, I should put an a out front. The square root graph starts at the origin, just generic form-wise. Because the square root of 0 is 0. The square root of 1 is, square root of 4 is, and then, so it's curving like this. That curve just moves an h and a k. The generic graph for a square root has your domain so that you want your square root to be positive, or excuse me, greater than or equal to 0. So in this original problem where it's x plus 4, that means that all my x values, my domain is going to be all my x values that are greater than or equal to negative 4, because I can't take the square root of negative. Does that make sense? So your domain is all x greater than or equal to negative 4. And now your range. The range is your possible y values. Well, your y values in this case start at negative 3 and then increase. So is it going to be anything less than negative 3 for y?
No.
No. So your y values are going to be greater than or equal to negative 3. It's a really easy thing to be able to interpret via the graph what the domain and range is doing, just by looking at it. Yeah?
I didn't get like what the graph in the bottom
The parent function, that's your parent function, just generic. If we did this via a table, we'd start with x values to y. We have 0, 1, 4, and 9. Gives us 0, 1, 2, and 3. That's how we get our order of pairs. So when we graph that, it would be at 0, 1, 1, 4, 2, 9, 3, and it's steadily increasing that way. What this does is takes it and just moves it an inch and a half. If there was an a value up front, it would just increase it or decrease it. It could reflect it by being negative with the calculator, by putting it in the calculator and remembering that domain stands for all your possible x values, and your range stands for all your possible y values. It is very simple to interpret that via the graph, and that's what I'm doing. Does that make sense? Let's see here. I know that I wanted to spend. Yes, sir. Sure. Did I tell you guys the shortcut for this?
Yes, you did. That's what,
Grouping?
that's what this one.
Can't group it right away, but what could I do? What would I do? I think it says state the possible zeros to start out with. So we're just looking at our tail divided by their front. So our possible zeros are going to be 1, 5, 7, and 35 plus and minus, and it's just all over 1. But what was it? What would we do? What were you saying anything? What was it?
You put in the calc, I don't know what we put in the calculator.
Oh, we just put the function in the calculator right away. Because obviously we could use synthetic division, but I'd have to do it, well, maybe 8 times to find a 0. If I take 2 seconds and I type in this function into my calculator right away, into the y equals, if I go right to my calculator and I type in x to the 5th, hello? should work. Next to the fifth, minus 5x to the fourth, minus 6x cubed. And I know your calculators are faster to do this than I am. Plus 30x squared, minus 7x, plus 35. If I just look at the graph right away, even on a 10 by 10, I might notice where the graph is crossing. You'll pick up right away that you're crossing at non-integer values somewhere in the middle there. Can I have a non-integer 0 here? That the rational root theorem is telling me I'm looking for just the regular integer values. So somewhere I'm going to have some crazy roots that I'll have to figure out later. But I also have, if I hit second table, I have a 0 located where?
5.
At 5. So by putting that in your calculator right away, it's going to help you decipher which one of those 8 possible zeros that you use first to use your synthetic division. It's a shortcut. That's why I didn't let you do that. I made you do it by hand.
It's not like I would have figured it out anyway.
Well, yeah, you would have, because I would have told you right away. So I used 5 because I know it's got to work. 1, negative 5, negative 6, 30, negative 7, 35. If we're lucky, we'll get a 0 at the end. So 1, 5, 0, 0, negative 6, negative 30, 0, 0, negative 7, negative 35, and a 0. Woohoo!
Yeah.
Yes, ma'am.
Yeah.
Well, if it's asking to find all the other zeros, it does work. I mean, what happens here is that in this case, you grouped it with the first 3 and the last 3. Oh, you did? You got the same GCF? Okay, it works. It's just sometimes if you use the calculator and you go through and get the zeros quicker, that's all. Because now I drop a degree, and I know it's x minus 5, x to the fourth, minus 6x squared, minus 7, and I can factor that like a regular old boring trinomial. What times what's negative 7 to get negative 6? I get plus 1 minus 7. So it's x squared plus 1, x squared minus 7. And now I can list out all of my possible zeros. I have 5, plus minus I, and plus minus root 7. That's the only reason why I use synthetic, because I can go right to a 0 and I get something real quick. But what you did is not wrong. Okay. Yeah, I think it's easy. Personally, I think it's easier to use synthetic, but if you want to group and go, it's fine. But remember, not everything's groupable. If it has a regular integer 0, you can always use synthetic. Okay, that's the only trick. Yes, sir.
Can we do number 68?
Sure. He's messing with you, absolutely. As your life coach, are you doing well? I sense that was weak in determining that your wellness is not strong.
Right.
You'll be fine.
Sorry, Captain.
65 or 68? 68, okay.
You can do the sugar?
Ooh.
Vertical asymptotes, x-intercepts, horizontal asymptotes, the whole shebang. Now, you think about this. When you graphed these before, you didn't have a calculator. Now you do. Okay? So you know that you have an x-intercept at negative 1, 0 of the numerator. I have a vertical asymptote at the 0 of the denominator at x equals negative 2. And then I'm looking for my horizontal asymptote. That's when you have to go through your 3 scenarios. In this case here, do they have the same, since they have the same degree, where's our horizontal asymptote? 1/4. At the fractional amount of the coefficients. Now, in a calculator, you can probably figure out most of that
Yeah.
just by putting it in the y equals. You'll see that you have an x-intercept at -1 by using the table. You'll see that you have a vertical asymptote at -2 because it's an integer value. It's going to show up in your table as an error message in the in the table. The horizontal asymptote might be the difficult one to find. You might have to be scrolling through and you might notice that it's approaching that value. Or you might have to just kind of look at the possibilities they give you in a multiple choice scenario to see which one of those makes the most sense. So they give you multiple choices of fourth, -4, 4, -4, something along those lines. So that's usually what they would do. You would look at your graph and calculate, you'd look at the graph. Which one of those makes sense? Okay. It's nice that you have the calculator now to be able to do these things. Just wait till second semester, then all of a sudden you get a calculator and you're gonna be like, wait, what is this machine? I love trig. Trig's so much fun. You guys will love it. Okay. Does that make sense?
Wait,
Cole, we all right on that then?
Yeah,
you have to tutoring.
What's that?
It's like the horizontal asymptote isn't just like the x values over 2.
Yeah, remember there's 3 scenarios. If they had the same degree, they would just be the coefficients. If one was bigger than the other, it was either 0 or it didn't exist. You would have the slant asymptote. Slant asymptote occurred when what? Remember that?
The numerator was bigger by 1 degree.
Correct. 1 degree larger than the denominator, and that's how you get the equation for the slant asymptote, and we go through that.
What's the vertical and horizontal asymptote? It's like, can you just like,
The vertical asymptote is when your denominator is equal to 0. It's the 0 of the denominator. Your horizontal asymptote, there are 3 cases. Remember, it was the same degree, the degrees.
Oh, yeah, wait, what is that? What's that's a slant asymptote.
What's that?
Oh,
degree.
it's just, okay, no.
It's those, yes.
Yeah, all right. Same degree.
Yes, sir. The slant's the one that it's fallen in and you can't get up.
Hey, Mr. Murphy,
Yes, sir.
what like button is for the matrix?
Matrix?
Yeah.
Alpha Zoom, I think?
yeah.
Alpha.
Is it that one? Is it Alpha Zoom?
Yeah.
Yeah, there we go.
Then you get the cases you can mix around with.
Yeah.
Identify the center and the radius of each. So, the generic form of a circle. Generic form of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. So in this case here, your center is going to be at -15 and 13 with a radius of
Sweet.
yeah, and a lot of and that it's nice. It's nice when you have it where I know what my radius is, and you go from there.
And these formulas are created.
Correctamundo. Yes, ma'am.
80 what? Okay.
All right. At least they tell you it's a parabola, so that's good. So you have a parabola. You have a vertex at -7 and -5. You have a focus at -7 and -17/3. -17/3, is that bigger or smaller? All right. Is it bigger or smaller than -5? I mean, it's kind of weird. It's
Negative.
it's more negative.
Yeah.
All right. So technically it's smaller, but it's just whatever. So that means it's down this direction. You okay with that? What direction is this opening?
Oh.
Down.
What?
Why? Because remember, you're always looking at your focus.
Oh.
Okay, you're always looking at your focus. So you're always doing that. So you know that you have a center. Excuse me. We have our form y minus k, x minus h. So it's a x minus h squared, I believe is how we had it written.
Yeah.
One of the choices is negative. So,
Yeah.
it would have to be negative.
Yeah. Louder.
After.
Let's say it louder. What she said was, once you know that the direction is moving downward, what's the only one of those that has a negative direction?
See.
Go to the next problem. Now, there are times you might have to figure out that the p-value and go through all of that. But a lot of times you might be able to get to it real quick by just that. All right? Okay. So in this case here, remember the distance from here to here, the distance from your vertex to your focus is, excuse me, is what do we do? We set that equal to p? Is that 4p? Oh, that's right, because it's 4p x minus h quantity squared y minus k. Okay. So that one is if it was from -5 to -5 2/3, if you will. Our distance would be -2/3. I think that's what we had, right? Because it was 17 thirds is 5 2/3. Two twelfths would be what? 1/6. What even 3/8? What did I screw up? Because p is the distance from. When did we do conics? It was what, September? What did I screw up?
I have no clue. Remember what conic is.
What's that? If this is -5 and this is -5 2/3, because it's -15, 17 over 3, that's our just. What did I? Is the p-value that? Why am I screwing this up? Why am I brain fart? Was what?
Unsolvable. It's C.
The distance between the vertex and the focus.
Let's see, this is butter questions? No.
Okay.
It's just a couple.
I was gonna pick one.
Duh. Oh, wait, no.
Wait, what is it?
P's distance from.
Yeah, what's the actual?
Did you get that? Yeah.
Distance
I went to
from.
the t-shirt area.
What is
all
this
you guys.
Okay.
I don't know what I was on.
Is P. Okay, so the distance. All right, sorry, not 4P. P is.
Oh.
P is the 2/3 part. Well, negative. Well, be positive is the absolute value. It's just going the other. What's that?
I'll just wait for you. But then how do you
I don't think it should be the negative. It should be.
How do you get like 3?
Your P value would be. This is 4P times that. Yeah, because the P value is the distance that is the distance from there. So your distance is
Not yet.
1. That's your P. So your P values, it's moved downwards, so it's got to be, we know it moved down.
Negative.
So why isn't it -8/3 and not, why is it -8/3 and not 3/8? That's what's messing me up here. I think this should be flipped. I think that's what was wrong. That fraction isn't right. I don't think the answer is right. Shoot. No, because because your distance is your p-value, and it's just opening downward, therefore it's got to be negative. So why is it? It should be 8/3, not negative 3/8. I know there's no typos on the final though. Where the center is at. Let's look at what is the 82's the other one you had to do the formula stuff with?
Yeah.
All right, let's do that one. That's got to be 8. It's got to be negative 8. I don't know why it's. I'll double check it.
So
That's-
P is
that's-
equal to 2/3 is what we need to know basically.
Basically, what you need to know is the direction is opening downwards. It means it's got to be negative.
Okay.
Pick that one and go to the next problem.
But what if there's 2 negatives? Then what do you do?
Pick one and go.
Yeah, true.
Same deal.
Let's go.
Okay. Same deal. You got your vertex and your focus. Plot them and see what direction it's moving. And then it's a matter of we have to figure out, well, is it going to be, see how you got 2 positives, 2 negatives?
I do see that.
By knowing what direction it's going to go, you're going to be able to cut out half of your possibilities. So vertex is at negative, or excuse me, 7 and negative 8. Focus, negative 97 over 12. Well, 12 goes into 97,
Oh,
8, be
8.08.
so 8 and a 12.
Yeah. It's like an 8.
So it's this,
Okay.
right? Below it.
It's like right next
So
to
we
it.
know it's got to be moving downward again.
Okay.
So we know it's got to be one of these two.
Got it.
So now it's just a matter of which one is your, bless you. So you have which value is going to go with the H, which one's going to go with the K. Yeah. B's the answer, isn't it?
Why is B?
Yeah, why is
Oh,
it B?
because I saw there's a 7 and an 8, so I just assumed.
What I'm trying to show you is that there's so many little shortcuts that you don't need to know everything.
Let's just put it in the calculator.
And that's a lot of it
Wait,
works.
Mr. Murphy.
And what happens here, hey guys, and you're right, you want to go through the whole shebang of, all right, how I get my distance, do I fill it in, substitute in, get the whole entire equation and whatnot, but, excuse me. What's that? If I know that, well, now do you agree that it's going to be a y minus h equals 4p x minus k quantity squared, but it's going to be moving downwards, so it's going to be negative. You agree on that, right? Now, here, without doing any other work, I know where my center, my vertex is. Okay? 7 and negative 8. So it's going to be y plus 8 equals negative 4p x minus 7 quantity squared. Right? If I just move this over, I'm going to get y equals negative 4p x minus 7 quantity squared minus 8. I don't have to do any other work except knowing that it's got to open downward and it's got to look like this just by moving stuff around, because I don't really care what that is, because I have enough information. Please stop copying those guys. I have enough information just to kind of work my way through it. That's the beauty of a multiple choice test. You don't need to do everything. It's one of those things, what's the least amount that I need to do? Typical teenager. Awesome. What's the least amount I have to do to get the answer? Okay. Now, by all means, we know that our distance here is a 12. I can set that equal to P and go through all the work.
So basically, you just take the vertex.
I wonder if they're using different format for their answers than what we did. I was just looking to try to find multiple choice questions with these and just pressing buttons. I didn't go at Kuda.
Oh.
Mr. Kuda. His first name's Barry.
Who's that?
Are you
Is he?
for real?
Is he?
Is he new?
I go by that.
I'll walk you through if we get through this.
You will wait for it.
Is this-
Very cool. Very cool.
Because I.
Math
I-
teacher.
Very cool.
That sounds like an FBI.
Isn't there a clue in the song?
Ooh.
Very cool.
It's the line of the song. It goes, ooh, barracuda. So when I was in high school, in our lunchroom, a long time ago, we had a thing called a jukebox. You ever heard of those?
Yes.
Yes. We had those in
Didn't they play those giant discs?
They would, it was actual records and 45s and stuff like that. And there was some person, I swear, every single day. Yes, sir. When did you graduate? 93. Every single day, somebody played Barracuda from Hearts in the lunchroom every single day for like a year straight.
I would probably.
It was pretty funny. So it's telling us that we have to identify the center and the radius. So we have to get in that generic format. Remember, the generic format for these guys is to wind up with your x minus h quantity squared, y minus k quantity squared equals r squared. And it was plus between the two, I believe. Okay. Now, what I need to do to make my life easier is to rewrite, put all the variable stuff to the other side, just to be quicker, okay? Flip-flop. You're going to get x squared plus y squared plus 2y minus 10x equals 74. All I did there is basically multiply everything by -1 just by moving things back and forth. I'm going to set this up to complete the square. I have x squared minus 10x plus blank. So over. Then I have y squared plus 2y plus blank equals 74 plus blank and blank. So far, so good? All right. What's half of -10? And then -5 squared is? So I have x minus 5 quantity squared, y plus 1 quantity squared equals 100. Where's your center and where's your radius? Okay.
Center is at 5.
Square.
It's 5 -1 radius of. Let's see here.
Radius of.
Is there another one you had to solve like that?
Identify the center versus.
Did we do 86 yet?
Those are not different.
No, we have not.
Oh, hey, let's do this one. Let's write the standard form of the ellipse with the roots and things.
Oh.
Then we'll go back and look at that parabola jump again.
What number?
Pretty sure.
88.
Remember, when you're dealing with these things again, you're looking at trying to figure out what direction they're moving, and then figuring out A, B's, and C's. So we know we have an ellipse. I just don't know if it's going to be, which one's bigger, the A squared or the B squared. I don't know which directions it's being stretched. So I plot it out. Let's see, we have -9, -9, 5, and plus 5 root 3, 5 root 5. Okay. What's 5 decimal equivalent-ish of 5 plus 5 root 5? 10-ish?
What?
16.
Oh, yeah, 10.
Is what it is.
5 plus 5 root 5? 16-ish?
I didn't see the plus.
Okay, 16-ish.
Right.
This rate's 16.
And then 5 minus 5 root 5.
Negatives.
What's 5 minus 5 root 5-ish?
-6-ish.
-6-ish?
Okay.
Okay. Now, what has to occur halfway between those two?
The center.
The center. Now, take a look at what happened. Where's the center?
It's exactly halfway between.
Oh, it's at 10.
Wait, with that.
Don't overthink it.
It's at 10.
1.
0.
No,
5.
10.
5.
it's at 5.
Yes.
I started at 5, I added 5 root 5, I started at 5, and I subtracted 5 root 5.
Yes. I knew it.
Got
Look
it.
at the focus.
It
The
was
focus.
It was the whole time.
I added 3 root 10, I subtracted 3 root 10. From what? 5. So you know your center is going to be at negative 9 and 5.
That was something special.
That's convenient. Now, if my vertices went that direction, and notice my focus are also going this direction, I don't know where they are, but what way is this being stretched? Being stretched vertically. Are we okay with that?
Yes.
So now I look at my calculator. In my calculator, if I'm looking at my conic stuff, don't worry, I'll take care of it. And I look at the ellipse. If I'm looking at the generic form for my ellipse, I now know that I have the b squared value comes first and the a squared value comes second. The a squared value is always the distance. Huh? The reason I know that is because see how the focus and the vertex are on the same vertical line? If they were horizontal, they'd be stretched this way, but they're stretched this way. Because your vertex always looks at your focus. So here, I know that the distance from the center to my vertex is 5 root 5, which is A. The center from here to C, bless you, is 3 root 10. I know that because that's what I added and subtracted from 5. Convenient how it writes it like that. From there, excuse me, if we start to fill in the blanks, we know that we're going to have, our center was what? At 9, or at negative 9 and 5. So I know it's going to be x plus 9, quantity squared, y minus 5, quantity squared. And it's always going to equal 1. I need to figure out my a squared value. So I take the quantity, when you use your calculator, if I do the quantity 5 root 5, oops. There we go. And I square it. That gives me my a values. My a squared, excuse me, 125. I do the same thing to find my c value, but I need to figure out b. But at this point, if I look at my possible answers, oh, I had to write it out. It wasn't multiple guess. I don't exactly. So I have to finish it out. In an ellipse, when you're trying to find, when you have your a squareds and your b squareds and your c squareds, is it addition between the a and b, or is it subtraction? It's subtraction. The reason we know that is because
You remember.
the formula of the ellipse is plus between the two. Therefore, the a squared b squared is subtraction. Remember, it's always the opposite. Same thing with hyperbola. Hyperbola is subtraction between the two terms. Therefore, the a squared is plus between the two. So I take 3 root 10, and I believe that's 90. So my c squared is 90. My a squared was 125. B squared will be, well, 125 minus something was 90. 35, right? So there's a b squared. But a lot of times you probably won't need to go that far if you're able to get just the figuring out what direction things are being stretched. Once you get that, then you know where the larger q is going to go. You're able to figure out real quick that the 125 is the a squared, and then we'll go out of that. Oh man, wow, we flew through this. I will do more conic stuff tomorrow. I will get back to you guys that leftover quiz that we took last week. I think everybody's just finished off on that one now. I do want to go over a few things about, what do you call it, exponent rules, and go from there. But yeah, we'll finish up more conic stuff tomorrow. I've had a lot of emails and questions about conic things. Okay? We'll get it. Yeah.